Hello everyone, today we're going to be solving AQA GCSE Chemistry Foundation Tier Paper 2, June 2022. This question paper is the part 1 of the video where we're going to be solving from question number 1 to question number 5. This question is about water. The student investigated pure water, the boiling point of pure water and the pH of pure water is measured. Complete the sentences. Pure water has a boiling point of 100 degrees Celsius. Pure water has a pH of 7. What could the student use to measure the pH of the pure water? The student can use, for example, a pH meter or universal indicator solution. A different student investigated seawater. Seawater contained dissolved solids. The student used this method. Measure a 50 cm³ sample of the seawater. Heat the sample until all the water has evaporated. Measure the mass of solid that remains. Repeat that steps 1, 2, 3, 3 more times. Which two pieces of equipment were needed for this investigation? Well, the student needs to measure the volume of the water the student is going to use. So measuring cylinder. And after the experiment is complete and before the experiment, the student needs to take the measurement of the mass of the apparatus. So a balance. Table 1 shows the result, seawater sample and mass of solid. Calculate the mean mass of solid that remained. To calculate the average or mean, we will add all of them and then we will just simply divide by 4. In this step, we must make sure that we leave off the anomalous results. However, in this question, there are no anomalous results, so 1.74. A 50 cm³ sample of seawater from a different source contained 1.50 grams of dissolved solids. Calculate the mass of dissolved solid in 1000 cm³ of seawater. To do this calculation, first of all, we will find out, since 50 cm³ contains 1.50 grams, so what will 1000 cm³ contain? Then we will divide the 1000 with 50 and then we're going to multiply it by 1.5. Sodium chloride is dissolved solid in seawater. Sodium chloride contains sodium ions or chloride ions. Complete the sentence. Student tested seawater for sodium ion using flame test. The color of the flame was yellow. Sodium gives yellow color. Potassium gives lilac color. And lithium ion gives crimson color. Complete the sentence. The student tested seawater for chloride ions by adding nitric acid and followed by silver nitrate. The color of precipitate formed was white. AGCL or silver chloride precipitate is white in color. This question is about hydrocarbons in crude oil. Table 2 shows information about 3 fractions from crude oil, fraction A, B, C. And we can see C as we go down, alright, they have a lower and lower boiling point. Figure 1 shows the fractionating column used to separate A, B, C. Alright, so where we are going to get? We're going to get fraction C at the top, fraction B at the middle, and fraction A at the bottom. Because the higher the boiling point you have, the faster you're going to condense in a fractionating column. So A will condense because it has a higher boiling point. It will condense sooner. The temperature of the fractionating column is 30 degrees Celsius at the top, 400 degrees Celsius at the bottom. Complete figure 1, ABC. So guys, we have already done it. Table 3 shows the information about 3 fractions obtained from crude oil. Petrol, 5 to 12. Diesel, 15 to 19. Heavy fuel oil, 20 to 40. Complete the answer from the box. Compared to petrol, the viscosity of heavy fuel is definitely higher because heavy fuel contains more carbon-containing molecules, which are viscous. Compared to petrol, the flammability of diesel oil will be lower. Since diesel oil contains, more carbon-containing molecules, so it will less easily evaporate, and as a result, catching fire would be a little bit different. Table 4 shows the percentage of 2 fractions obtained from 2 different sources of crude oil. NOC, heavy oil, sources J and K. Complete the y-axis scale. Plot the percentage of heavy fuel oil fractions obtained from source K. So J is already done. Now K, 44. So this is 10. Then the next one will be 20, 30, 40, 50. And K is 44. Kerosene is in higher demand than heavy fuel oil. Suggest why crude oil from source J is higher demand than crude oil from source K. Crude oil from source J contains a higher percentage of kerosene. For those of you who don't know, kerosene is aviation fuel. So as we fly a lot of planes, we need lots and lots of kerosene. Large hydrocarbon molecules can be cracked to produce smaller hydrocarbon molecules including alkenes. Which two of the following can be used to crack large hydrocarbon molecules? We can either use a catalyst to crack it down or we can use steam. Alkenes have general formula CnH2n+2. Complete the formula of the alkene containing 11 carbons. So it will be 11 times 2 plus 2. C11H24. C2H6 is an alkene. Which type of bond is found in C2H6 molecule? So let's draw the molecule of C2H6. It contains one single carbon-carbon bond. 6 CH bond. Double bond. There are no double bonds. So there are a single bond between two carbon atoms, yes, we can find this. Which two substances are produced when alkenes completely combust? When any alkane, for example, a methane, is burned in oxygen, it produces carbon dioxide plus water. That's a must. Now, carbon dioxide and water. However, incomplete combustion will also produce carbon monoxide and water. This question is about Earth's atmosphere, the estimated percentage of gases in the Earth's early atmosphere, and the percentage of gases in the Earth's atmosphere today. So nitrogen was 1.8%, and now nitrogen is 78%. Calculate the value of X in table 5. To calculate such values, we know the total percentage is equals to 100. So 100 minus 20.95 plus 0.04 plus 0.92, which gives us 78.09%. We're going to write down the whole answer because they didn't ask us to do it in significant figures. Which two other gases may have been in the Earth's early atmosphere? In the Earth's early atmosphere, well, coal, limestone, alright, and polyethylene will not be available because none of them are gases at normal room temperature and pressure. So there could be ammonia, there could be methane. They can be produced, alright, if there is animals present, or they can be produced if there is, the certain conditions on Earth that makes it possible that methane and ammonia is produced. Algae and plants increase the percentage of oxygen in the Earth's atmosphere. The same process in algae and plants decreased the percentage of carbon dioxide in the Earth's atmosphere. Which process in algae and plant increased the percentage of oxygen in the Earth's atmosphere? Definitely photosynthesis, because plants and algae, they're very good at doing photosynthesis, where they absorb carbon dioxide and produce oxygen. Which two other processes decreased the percentage of carbon dioxide in the Earth's atmosphere? We know that apart from carbon dioxide absorption in photosynthesis, when carbon dioxide got dissolved in oceans, they got removed from the environment, and eruption of volcanoes actually can introduce carbon dioxide. Burning of fossil fuel can introduce carbon dioxide. Evolution of animal can increase carbon dioxide because they respire carbon dioxide. So formation of sedimentary rocks, when they form calcium carbonate and carbonate-like molecules, they can trap CO2 with them until we extract it. This will be the correct answer. Figure 3 shows how the percentage of gases in Earth's atmosphere may have changed since the atmosphere was formed. You can see carbon dioxide, nitrogen, and oxygen. The percentages of the gases on Earth's atmosphere represented over here in the diagram, and we can see that how different gases are formed over what period of time. Okay. When was the percentage of oxygen in the Earth's atmosphere? 8%. 8% is this much, and that was in 1500 million years ago. When did the percentage of nitrogen in the Earth's atmosphere become constant? We will extrapolate, and when we extrapolate, we find out that it was near 2600 million years ago. Crude oil was formed from an ancient biomass as Earth's atmosphere evolved. What did this ancient biomass mainly consist of? Sand is silicon dioxide, limestone is calcium carbonate, so organic substance is plankton. The plankton contained, fatty acids inside them, which converted into crude oil. Most of the percentage of the gases in figure 3 are estimated values. Why scientists use estimated values for the percentage of gases in figure 3? Because, there are 1500 years ago, or 1500 million years ago, or 2000 million years ago, very little evidence for that time scale. This question is about ethanol. The formula of ethanol is C2H5OH. Complete the displayed structure of formula of ethanol. In order to complete it, we have to understand a carbon can have maximum of 4 bonds. Oxygen can have up to 2 bonds, and it will have 2 bonds. And hydrogen can only have 1 bond. So oxygen will have 2 bonds, and hydrogen will have 1 bond. Which is one use of ethanol? Ethanol, first option, as a protective coating on aluminium. No, we do not. We cannot use ethanol as a protective coating. However, we can use ethanol in hand gels to kill microbes. We do not use ethanol for the presence of hydrogen gas. Ethanol by itself is flammable. Ethanol is used as a solvent in some inks. A student used paper chromatography to show that an ink contained 2 different dyes. Figure 4 shows the apparatus at the end of the investigation. Describe a method the student could have used for this investigation. When we are asked about chromatography, first thing we will think of is we are going to talk about the drawing of the pencil in a start line. So we will draw the pencil in a start line using pencil. Then we're going to place the spot of the ink on the start line. All right. And depending on what kind of substances we are trying to test, can use alcohol as an indicator. All right. Or we can use water as we can use alcohol as an solvent or water as an solvent. Okay. Then we're going to place that in a solvent in the beaker. We're going to place the paper in the solvent so that and we're going to be careful so that the solvent is just below the start line but doesn't touch the start line. All right, we're going to put a lid so that the solvent does not evaporate. We will allow time for the solvent to travel up the paper until it reaches near the top. All right, and until it reaches near the top, but it must not reach the top, okay? Because otherwise, if it reaches the top, then the experiment will be invalid. Then we will dry it and we will then count the spots to actually tell how many dyes were present within that particular ink we were testing. What must be added to sugar solution to produce ethanol? So ethanol requires yeast. To produce ethanol, sugar requires yeast. All right, yeast has enzymes that can convert sugar into ethanol during anaerobic respiration. E5 and E10 are types of fuel used in cars. These fuels contain ethanol and petrol. E5 and E10, 5% and 95% petrol. E10, 10% ethanol, 90% petrol. Calculate the mass of ethanol in 4.4 kilogram of E5. To find out the mass, all right, we will first multiply 4.4 into 5%, and then we'll get the mass of, then we're going to get the mass of alcohol in 4.4 grams. Since they want the LSAT in grams, so we will convert it 0.22 times 1,000, 220 grams. The ethanol E5 and E10 is produced from sugar. Sugar is produced from plants. Explain why the production of E10 removes more carbon dioxide from the atmosphere than the production of E5. E10 contains more ethanol, and the ethanol is produced from sugar. E10 contains more ethanol than E5, and the sugar is produced from, and the ethanol is produced from sugar. So more sugar is used in the production of E10. So more carbon dioxide is absorbed by the plant when growing and making the sugar. Table 5 shows the energy content of ethanol and petrol. Ethanol 30 megajoules per kilogram, 46 megajoules per kilogram in petrol. So this is one disadvantage of using E10 instead of E5. Since E10 has more amount of ethanol in it compared to E5, so since ethanol has less amount of energy in it, that's why E10 produces less amount of energy per liter compared to petrol. Ammonia is produced in the Haber process. The raw material for the Haber process are nitrogen and hydrogen. Draw one line for each of the raw material and the source of the raw material. Nitrogen we collect it from the air during the Haber process. Hydrogen we usually take it from natural gas during the Haber process. What are the states of nitrogen and hydrogen when used in Haber process? So in Haber process, we use the nitrogen as it is a gas. All right, as it is. And state of hydrogen is also gas during the Haber process. So both are gas. The word equation for the production of ammonia, hydrogen plus hydrogen produces ammonia in a reversible reaction. Atomic economy of the reaction is 100%. How does the word equation show that the atomic economy is 100%? All of the reactants are converted into product. So there is only one product. Figure 5 represents the Haber process. You can see nitrogen and hydrogen coming to the reactor. Nitrogen and hydrogen and ammonia. So ammonia has already formed. It comes to the other one where ammonia is extracted by cooling it down or by using pressure to convert it into liquid, whereas nitrogen and hydrogen stays like a gas. They are put back into the reactor back again. So the process can continue indefinitely. A mixture of nitrogen, hydrogen and ammonia enters X. In X, the mixture is cooled. Ammonia can be removed from X because ammonia at low temperature becomes liquid. So ammonia is liquefied. Unreacted nitrogen and hydrogens they get recycled back into the system so that they can only produce ammonia. Once they produce ammonia, they can leave the reactor. Figure 8 shows the percentage yield of ammonia in different in different pressures. You can see as the pressure increases, the percentage yield also increases. 200 atmosphere peak pressure is the one that we use in the industry. Plot the data in table 8 or figure 6. What is the effect of increasing pressure on the percentage yield of ammonia? Percentage yield increases as we keep on increasing the pressure. Alright guys, we're done with question number 5. That's all for today's video. Guys, inshallah, see you in the next video. Thank you for watching. Bye-bye.